A very important application of forward difference operator, and this is so that if delta operates on n, then delta nx plus 1, this is equal to nx, this is ncx plus 1 and this is ncx, and hence so that this result. Okay, and we know the notation that ncx we write also this is in the form of nx. This is the another notation of convention. Okay, now we clear the definition of delta. Delta fx means fx plus h minus fx. Okay, and h with a step length and it work with independent variable. Now when we write the definition of delta n x plus 1, if we write this is n x plus h plus 1 minus n x plus 1, so this definition is wrong. Why wrong? Because in ncx x is not independent variable, because we know that in ncx x varies from 0, 1, 2 to n, that is depend on n. Here if we change the value of n, then changing the value of ncx. Okay, and we say that n is the independent variable. So the correct definition of delta ncx plus 1 is delta ncx plus 1, this is given by n plus 1 cx plus 1 minus ncx plus 1, because if we take the step length is h, then h may be fraction, but we know that if we write here n plus h cx, then this is not defined, because it is defined only for the integral value or positive integral value. So we here taking the step length h, this is equal to 1, and this is the definition of delta. Okay, now we know the relation of combination as ncr minus 1 plus ncr, this is equal to n plus 1 cr. We know it. Okay, that is we write that n plus 1 cr minus ncr, this is given by ncr minus 1. Now here we put r, this is equal to x plus 1 to get this result. Okay, and getting that n plus 1 cx plus 1 minus ncx plus 1, this is equal to ncx, because here r means x plus 1 minus 1, so ncx, and we get the result as delta nx plus 1, this is equal to ncx, and this is our first result. Okay, now if we name this relation as relation number 1, and in relation number 1 we put the value of n, this is 1, 2, 3 to capital N. Okay, and write the result one by one in vertical line, then we get 1 cx, this is given by the right side is, this is 2 cx plus 1 minus 1 cx plus 1, because n equal to 1 we put, and in the second line we put n equal to 2, then we get 2 cx, and the right side is 3 cx plus 1 minus 2 cx plus 1, and now 3 cx, similarly we get this is 4 cx plus 1 minus 3 cx plus 1, and so on. We put the last value of n, this is capital N, so capital N cx, this is given by capital N plus 1 cx plus 1 minus capital N cx, and adding all of these results we get the left side, this is equal to this is summation n equal to 1 to capital N, and this is ncx. Okay, because here n equal to 1 to capital N, this is n equal to 1 to capital N, and the right side is getting as this cancel out, this cancel out, so this term also cancel out with this term, so we get the result is this minus the first term. So this is N+1 cx+1 minus 1 cx+1. Okay, and this is the result in the right side, and this is very important application of forward difference operator. Okay, thank you for watching.